Let's begin with some background information. The laws of motion were discovered in 1666. They were discovered by Sir Isaac Newton, a famous physicist. Newton was born on December 25, 1642, and passed away on March 20, 1727. Newton had many influences, one being Galileo, a famous scientist who lived before his time. Newton is credited for discovering gravity. Newton was also an inventor and is known for building a telescope. And when it comes to his discoveries outside of science, we can thank him for creating calculus, everyone's favorite. Newton is also called the father of modern physics thanks to his discoveries of the laws of motion. When it comes to kinesiology, the best application for Newton's laws of motion can be seen in the subdiscipline of biomechanics. Understanding the laws of motion and biomechanics is important because it helps us understand the movement of the body and how to make it the most efficient and also how to treat it. Alright, now it's quiz time. Who discovered the laws of motion? Think about it. Keep thinking about it. If you guessed Sir Isaac Newton, you were correct. The first law of motion is also called the law of inertia. Inertia is the body's resistance to change. The original law states, a normal body will continue in its state of rest or uniform motion unless acted upon by an external force. This means that the body will maintain its rest or its normal motion until something, which is the external force, causes it to change. An example of the law of inertia when applied to linear movement is, in this case, Ralph rolling down a hill. Ralph will continue to roll unless friction, which is the force in this example, stops him from rolling. When the law of inertia is applied to angular momentum, it becomes the law of conservation and angular momentum. The original law states a rotating body will continue to turn about its axis of rotation with constant angular momentum unless acted upon by an external couple or eccentric force. This means if a body is rotating, then it will continue to do this with the same amount of momentum unless a different force causes a change. An example that can occur every day of the law of conservation of angular momentum is the example of the passenger in a car that makes a sharp turn around a corner. When the body moves to the window because of the pull of gravity, the body is pulled off of its normal axis. Without this change, the body would have stayed in its normal place. Now it's time for everyone's favorite activity, quiz time. This question is, what is the law of inertia? Not quite sure yet? Let me make it multiple choice. Your answer choices include A, which is gravity, B, the body's resistance to change, or C, I'm gonna pick C because C is always correct. If you picked C, you are incorrect because the correct answer is B. Inertia is the body's resistance to change. Newton's second law is known as the law of acceleration. The original law states the acceleration of a body is proportional to the force imparted to it and inversely proportional to the body's mass. Acceleration can be formulated A equals F over m. The translation of this is that the amount of acceleration is connected to the amount of force applied and is also dependent on the body mass of the person. Saying the body mass is the same and the amount of force inflicted increases, the acceleration will also increase. An everyday example of this is that it's easier for someone to lift a 2-pound weight faster than a 20-pound weight because the 2-pound weight has less mass. This example only works if the person is exerting the same amount of force onto the object. applied to angular motion, the second law states the angular acceleration of a body is proportional to the torque causing it and takes place in the directions to which the torque acts. Acceleration in this case equals T for torque over I for inertia. This means the acceleration of an object is connected to the torque that caused it, and it continues in the same direction as the torque. An example of this can be seen during a bicep curl. Holding a weight, the weight and the gravity is the force pulling the arm downwards. The movement starts at the fulcrum, or in this case the elbow, and the resistance of the muscle moves the limb, the muscle in this case being the bicep and the limb being the arm. The muscles create the torque needed to move the arm into a flexed position and then down again to be in an extension position to complete the bicep curl. This movement is best understood using biomechanics, and by understanding these biomechanics, a physical therapist or an athletic trainer can teach an athlete how to properly achieve and do this skill. It's everyone's favorite time again! The question is, what is Newton's second law called? That's correct, the law of acceleration. Newton's third law is called the law of action and reaction. The original law states, when one body exerts a force on another, there is an equal, opposite, or simultaneous reactive force imparted on the first body from the second. This means that when the first body inflicts force onto the second body will inflict an equal or opposite force on the first body. This force may occur at the same time. A real-life example of Newton's third law is seen in volleyball. When a volleyball player jumps in order to protect the net or to spike the ball, they apply force into the ground, and the ground in part inflicts force onto them, propelling them off the ground. When this law is applied to angular movement, it changes slightly. The original law says, for every torque exerted by one body onto another, there is an equal, opposite, or simultaneous torque exerted by the second body onto the first. This means when one body applies torque to another body, the second body will inflict an equal or opposite amount of torque onto the first one. This daily life example is slightly complicated and comes from the website opentextbc.ca. An ice skater is spinning on the tip of her skate with her arms extended. Her angular momentum is conserved because the net torque on her is small. In the second image, her rate of speed increases greatly when she puts her arms in, decreasing her moment of inertia because her arms are no longer resisting the change, and the change is her spinning. The work she does to pull her arms in results in an increase of rotational kinetic energy. As she pulls her arms in and decreases her resistance to change, or her inertia, she's able to spin faster because she's not resisting the change as much. Congratulations, you've made it to the last quiz time. What is the resistance to change in the example with the ice skater? That is correct, her arms being out. Good job. Now that you know the basics, you're ready to take on the world of biomechanics. Congratulations, and thank you for watching my video.